We're still in section 2.7. We're solving inequalities and writing in interval notation. Our next problem is 4x minus 7 is greater than or equal to 5. Remember, we'll work on the x side and we want to move the 7 first. So I'm going to add 7 to both sides. So that tells me that 4x is greater than or equal to 12. To get x by itself, right now it's being times by 4. The opposite of times is to divide, so we'll divide both sides by 4, and x is greater than or equal to 3. Writing this one in interval notation, I'm going to start at 3 and go to the right, so that would be from 3 to infinity. Remember, infinity always takes parentheses. The 3 will have a bracket because it's equal to. Your final answer is 3 to infinity. If you need to draw the number line, feel free to draw the number line. Make sure that you can get from x is greater than or equal to 3 to the interval notation form. My next problem is x minus 1/3 is greater than or equal to 5/6. There are two different ways to work this problem. In section 2.1, for equations, we worked this one by adding 1/3 to both sides, and that way would definitely work. The second way we can work it is by canceling out fractions, and that's how we worked our equations in section 2.3. So I prefer to work it by canceling out the fractions. So I'm going to rewrite the problem and make sure all of my whole numbers turn into fractions. So I would have x divided by 1 to make x into a fraction. X divided by 1 minus 1/3 is greater than or equal to 5/6. My common denominator for 1 and 3 and 6 would be 6. So what I'm going to do is put a 6 in every top. When I do that, each of those three fractions is going to simplify. My first fraction, 6 times x over 1, is just 6x. My second fraction is 6 divided by 3, which I know is 2. You could have also worked that one by saying 3 goes into 6 2 times. Remember to bring down your inequality sign, never change it to an equals. In my last fraction, I have 6 times 5, which is 30. 30 divided by 6 would give me a 5. You could also work that fraction by saying a 6 in the bottom and a 6 in the top would cancel out and leave you with 5. Now we have to get this x by itself, so we need to move the 2 and move the 6. We'll move the 2 first. So I'm going to add 2 to both sides. And 6x is greater than or equal to 7. Now remember, you're working on the x side. So to get x by itself, we're going to divide by 6 on both sides. And so I get that x is greater than or equal to 7/6. In interval notation, that would be from 7/6 to the right, which would be 7/6 to infinity, and 7/6 will take a bracket since it was an equal to. Okay, so let's keep going. My next problem is negative 2x plus 3 is less than 9. The first thing I'm going to do is move my 3 over, so I'm going to subtract 3 from both sides, and negative 2x is less than 6. To get the x by itself, I'm going to divide both sides by negative 2. Remember, this is a special rule. When you divide by a negative, you have to flip the sign. So you'll notice that I flipped the sign here. So x is greater than negative 3. In interval notation, that would be negative 3 to the right, and to the right would be infinity. The negative 3 would use parentheses. Next problem is 9x minus 6 is less than or equal to 7x minus 20. First thing we need to do is get our x's on the same side. So I'm going to subtract 7x from both sides. What's left over would be 2x minus 6 is greater than or equal to negative 20. Working on the x side, I'm going to move the 6 first, so I'll add 6 to both sides. And 2x is less than or equal to a negative 14. The way I got negative 14 is I noticed they had different signs. Different signs tell me to subtract and take the sign of the larger. So that's how I got negative 14. I'm going to divide both sides by 2 here. I notice that 2 is a positive number, so that means no flipping. So x is less than negative 7. Some people think that because the 14 is negative or because the result is negative that you flip, but you only flip based upon what you divide by. So since I divided by 2, which was positive, no flipping. You'll see that the arrow here in the less than is pointing towards the left. That means we're going to start at the left with negative infinity and move to 7, that's negative, and we have a parenthesis there. So negative infinity to negative 7. My next problem says negative 5x is greater than 15. To get the x by itself, I'm going to divide both sides by negative 5. And I know when I divide by a negative, I have to flip my sign. So x is less than negative 3. Since I divided by negative 5, I had to flip my sign. Writing this one in interval notation, it's pointing towards the left, which means infinity's on the left, and the infinity on the left is negative. So this would go negative infinity to negative 3. Infinity always has parentheses, and the negative 3 will have a parenthesis because it's not equal to. Remember, if you need to draw the number line out, by all means draw the number line out. Our next problem is 5/6x is less than negative 20. I'm trying to get the x by itself. So to get the x by itself, I need to get rid of the 5/6. To get rid of a fraction like this, you multiply by its reciprocal, and the reciprocal means flip it over. If I put a 6 on the top, that would cancel out the 6 on the bottom, and if I put a 5 on the bottom, that would cancel out the 5 on the top. But the rule is if I multiply on the left by 6/5, I have to also multiply on the right by 6/5. So simplifying, on my page, a 6 in the top and a 6 in the bottom cancel, a 5 in the top and a 5 in the bottom cancel, and x is less than some number. On the right-hand side, I have 6/5 times negative 20. I'm going to put that negative 20 over 1, and I know my answer will be negative. Multiplying these two fractions, I can cross-reduce first. 5 goes into 20 4 times. So what I'm left with is 6 times 4, which would be 24. I've already taken care of my sign, so x is less than a negative 24. It's pointing left, which means infinity's on the left, and that's negative infinity. So it goes from negative infinity to negative 24, and negative 24 uses parentheses.